All right, hi class. I hope you guys are doing well. All cooped up at home and quarantined. This is day 2 of our quarantine cycle here. It's going to be, I think, a long 2 weeks, but we're hanging there. So just wanted to create a quick video for you guys, for those of you guys who are trying to do the right hand rule. That's this one where we're going to use our right hand and to help you guys out with that homework. So let's get started. So quick review here. Oh, that didn't work. There we go. Alright, so quick review. From last time we looked at magnetic fields, we talked about how different things have a magnetic field. So the standard bar magnet has these lines that we saw around them using the magnetic filings, or the iron filings. Other things have magnetic fields as well that we've discovered, things that have charges moving through them, like wires and loops and solenoids. So let's figure out what this means to us. So a moving electric charge is surrounded by the magnetic field. What this means is that when you have a charge that's moving and it goes through another magnetic field created by a permanent magnet or some other thing, it will feel force. We have this relationship between the velocity, or the direction that a charge is moving, the magnetic field, and the force. And all three of these vectors are 90 degrees with respect to each other. So we're going to skip this slide, and we'll come back to this in a future assignment. But the force that is felt by a moving charge is given to us by the equation QVB, where the force is the force felt on the charge, measured in newtons. Q is the charge, measured in coulombs. V is the velocity that the charge is moving, measured in meters per second. And B, this is a new variable that we're using, represents the magnetic field, and that is measured in a unit called Teslas. So let's take a look at an example here. So in this example, we have a magnet that is going from left to right. We define the magnetic field to be from north to south, and we have a charge that is coming out of the page towards us with a velocity v. Now, if we use the right-hand rule, the right-hand rule is defined as the following. We're going to use our index finger, and our index finger is going to point in the direction that the charge is moving. So that means coming out of the page. Let's see if I can do this. So, coming out of the page, that's this way. Our middle finger now points in the direction of the magnetic field. That means from left to right. So I'm going to turn my hand here so you can see my middle finger is pointing from left to right, or the palm of my hand is going from left to right. And now the thumb, my thumb points in the upward direction. So that is the direction that the force is felt on that charge. So that's up. So a couple things that I want to note here. So we can't keep drawing our problems in 3 dimensions. So in this one, we can see that the charge is coming out of the page, and we've drawn that 3-dimensionally here to come kind of down and to the left. But a lot of our problems are going to be drawn in 2 dimensions, and so we have a notation here that we're going to define as orientation and motion. So all the problems we're going to look at will either be moving up, down, left, or right. That's up, down, left, right with arrows. And then to show that something is coming into the page, we're going to use an X. And to show that it's coming out of the page, we're going to use a dot. The X and dot notation follow the following mnemonic. I want you guys to think about an arrow coming out of the page has a small dot, the arrowhead. You're just looking at the point of the arrow. And if the arrow is going into the page, you're looking at the tail of the arrow, and that's the X. So let's take a look at an example here. So here we've got a charge that's moving from right to left. Let me show the camera here again. Let's see. I think it's this one. Alright, so now you guys can see me. So I'm going to use my finger. I'm going to point to the left with my index finger. That's the direction the charge is moving. And the dots indicate that it's coming out of the page. So now I'm going to again hold my finger coming out of the page towards me. That's my middle finger is coming out of the page. And my thumb is pointed up. So that means that the force is being pushed up on that charge. Now I want you to notice here that this rule works for positive moving charges only. Positive moving charges. We'll see a couple examples where that changes here. So let's take a look at another example. So here we have a magnetic field that is directed out of the page, and the charge is moving in the upward direction. So I'm going to take my right hand again. I'm going to use my index finger and I'm going to point straight up. That's the direction that the charge is moving. And now I'm going to have to do a little rotation. I'm going to turn my hand so that the middle finger, or my palm, is coming out of the page towards me. Coming out of the page. And then that results in my thumb pointing to the right. Pointing to the right. So that means that the magnetic force on this charge moving through this field will be going to the right. And so let's see. So that means that the force is pointing to the right. And if we animate this, that means that the charge is accelerated or being pushed to the right and arcs to the right, just like that. So now if we take the same example, here this is for a negative charge, so magnetic field is directed out of the page. Now we want to predict the direction that the force is going to be felt on this charge. So again, I'm going to use my finger, my index finger. I'm going to point up, my right hand pointing up. That's the direction the charge is moving. The magnetic field, that's the middle finger, is going to come out of the page. So I'm going to turn my hand this way. And my thumb is pointing to the right. Now, the force on this charge is not to the right because it's a negative charge, so I'm going to have to flip it. So that means that now the force felt on this negative charge is to the left. So to the left, and that means that it arcs to the left. So you guys can stop this if you feel comfortable with it, or speed ahead, and I'll go through some of the examples on the homework. But I want to do one more example with you guys here. Let's see. Alright, so this is a good one. Alright, so now we have a charge moving in the upward direction, and we have the B field, or the magnetic field, going from left to right. You can see the arrows there. So again, I'm going to take my index finger and point up, and then the middle finger here, that's the palm of my hand, is going to have to go from left to right. So I have to turn my hand all the way around this way. So that's going left to right. And now my thumb is pointed into the page. So into the page, and to show that it's going into the page, I'm going to use the X notation to show that it's going into the page. All these slides are posted on Classroom, and you guys can click through them and see the answers there to help you out. So let's flip to the homework problem that you guys have. Let's see. So you guys had some problems here to work on. They look like this. So we'll take a look at these examples here. The first row. The first row here, we're going to take a look at. I'm actually going to skip this one. I'm going to go to the second one first. Here I have a charge moving from right to left. So I'm going to take my index finger, my right hand, and I'm going to point to the left. The dots indicate that the B field is coming out of the page. So I'm going to write this here. Out of page. Alright, so I have my index finger going to the left. That's the direction the charge is moving. My middle finger is going to rotate up out of the page this way, and my thumb now points in the up direction. So I would say in this one, the force being felt, F, is up. And this works for a positive charge. Now, I'm going to go back to this one here. This one is the exact same scenario, but what's different is it's a negative charge. Now, so for a negative charge, we're going to do the same thing. So my index finger points from right to left. My middle finger points up, coming out of the page. Thumb is now going up on the page, And so, but it's a negative charge, so that means that the force felt on this charge is down. We'll do a couple more here so you guys can see it. The third one, I have a charge oh, these are different. I'm noticing these are different than the ones that are on your page. Hold on. Okay. Alright, so sorry about that. So this is the worksheet that you guys have. So the third one here, let's take a look at the third one. The third one, we have a charge going from the right to the left. Now remember, the X's mean that the charge is going into the page. So into the page. So I'm going to use my right hand. I'm going to point from right to left. The charge is moving right to left. My middle finger is going to point in the direction of the magnetic field. That's B. So I'm going to turn my hand down this way. And my thumb now points down on the page this way. So on this one, we have the charge moving through the field here, and the force being felt is going down. The fourth one, we have a charge sitting in a field that's not moving. Remember, the equation is F is equal to Q times V times B. And if the velocity is 0, it means it's not moving, then there's no force. So no motion, no force. And we'll do a couple more here, and then the rest I'll leave for you guys to do for homework. So the fifth example here, we have a charge moving from left to right. And so again, I'm going to take my right hand and I'm going to point this way. It's a little hard to do this, but I have to rotate my hand so that I'm pointing with my index finger from left to right. The magnetic field comes out of the page. Remember, the dots mean it's coming out of the page, so my finger comes out. And I can't quite do this with my hands, but so this way. And my thumb is now pointing down. And it might be helpful, sometimes it's helpful to rotate the page so that your hands line up. Right, so here, my index finger is pointing this way. I'm going to line up my index finger that way. My middle finger is pointing up or out of the page, and my thumb is pointing down. So in this one, we have the force going down. Example number 6, we have the charge moving again left to right, and the magnetic field is also left to right. one of the things I want you guys to notice here is that when I hold my hand, I have my charge moving in the direction of the index finger. The magnetic field is the direction of my middle finger. My thumb is the direction of the force. All three of these things are 90 degrees with respect to each other. Always 90 degrees. If it's not 90 degrees, it doesn't work. So in this case, I have the charge moving from left to right in the same direction as the magnetic field. So because they're parallel, there's no force. Parallel to B field. So there's no force. And then I think we'll do this last one here. Just there's a few of these that are a little tricky. So this one here, I'm going to take my index finger. Now I'm going to point kind of up and to the left. Up and to the left. The magnetic field is coming out of the paper. So I'm going to turn this, and my finger comes out of the page this way. And my thumb is going up and to the right at a 90-degree angle. So this way. So the force being felt on this charge is this way. And it would be that if it were a positive charge, but because this is a negative charge, the force felt on it is actually the opposite direction. So over here. So remember that the right-hand rule only works for positive charges. Because this one is a negative charge, the force, we just flip the direction of the force, and the force is going down to the left. I'm actually going to do one last one, and then you guys will have the rest to do. When you're done with those, take a picture of it and upload it to Classroom for me to grade. So let's take a look at this one. This one says that the velocity of the charge is coming out of the page. So out of the page. And the B field goes from right to left. So I'm going to take my index finger. Now I'm going to point up. Sorry, not up, but out of the page. I'm going to my index finger coming out of the paper this way. And then I'm going to turn my hand so that my middle finger points from right to left. So this, and let's see, how do I do this? So this, right? So my index finger is still pointing up, and my middle finger is pointing to the left. My thumb now is pointing down, and I can't quite show this with the webcam, but basically here is how that looks, right? So I'll do this again. So the velocity of the charge is, the velocity of the charge is going into the paper, I'm sorry. So pointing down, and then I'm going to rotate my hand so that my middle finger, that's this one here, is going from left to right. And now my thumb is pointing up. But this is a negative charge, so instead of the force being up, the force is going to be down. Right, because it's a negative charge. So, couple things to remember. One, your index finger points in the direction the charge is moving. Your middle finger, or your palm of your hand, points in the direction of the magnetic field, or B. And then the thumb points in the direction of the force. The other thing is to remember that these three vectors, or these three directions, are always 90 degrees with respect to each other. We'll do actually one last example, and I think that will be one of the ones with a wire. So let's take a look at this one right here. So this one right here, we've got the wire carrying the charge. The charge is going in the up direction. That's this way. So I'm going to point my index finger up. The magnetic field, B, goes from left to right. So now I have to turn my hand so that my middle finger on my right hand goes from left to right. And then my thumb is now pointing into the page. Right? So And the last thing as a tip to remember, so the ones that have the permanent magnet here, here, and here, is to remember that magnetic field B is defined from north to south. North to south. So give that a try. Email me if you have any questions. I will be online every day during the day. You can also jump onto the chat. I'll be sending out some information about our new Google Chat classroom link as well for you guys to ask me questions directly. And otherwise, I hope you guys are doing well, and I will talk to you guys soon. Take care. Bye-bye.